Simultaneous equations. The way that we solve these is by a process called elimination. The idea being that we're going to get rid of or eliminate either the x's or the y's. Now, if you happen to have the same number of x's, which we don't here, we've got 2x here, 5x here, or you might have the same number of y's, but again we don't, we've got 3y and 4y. If you don't have that situation, you need to make your equations, adjust your equations so that either the number of x's are the same or the number of y's are the same. Now, in this case, and this will always be the case if you have a choice, it's easier to make the number of y's the same. And the reason for that is it means that we're going to be able to add the two equations together, because we'll have a negative number of y's and a positive number of y's, and those will cancel each other out. It's always easier to add the two equations if you can. So the first thing I'm going to do is take the first equation and I'm going to multiply it by 4, because I know that that's going to give me minus 12y. And at the same time, I'm going to take the second equation, I'm going to multiply it by 3, because I know that's going to give me plus 12y. Remember to multiply the whole equation by 4. So multiplying the first equation by 4, 2x multiplied by 4, well that's just 8x. Minus 3y times 4, well as we've said, that's minus 12y. And then 9 times 4 is 36. I'm going to call that equation 3. Now I'm going to multiply the second equation by 3. So 3 lots of 5x, well that's just 15x. 3 lots of 4y, well that's plus 12y. And 3 lots of 11 is 33. And I'm going to call that one equation 4. I can now see that I can add equation 3 to equation 4, because I'm going to have minus 12y add plus 12y. Those are going to cancel each other out, or disappear. So 8x plus 15x, well that's 23x. As I've said, the y's have disappeared. And I'm now going to add 36 and 33, well that's 69. So 23x is equal to 69. If I now just divide both sides by 23, if I divide the left-hand side by 23, I get x. If I divide the right-hand side by 23, well, 3 23s make 69, so x is going to be 3. So I've found out what x is. Now I need to find y. So I'm going to substitute back into one of these equations, and I think the easiest one to choose is probably that second one, where 5x plus 4y is equal to 11, except I now know that x is 3. So 5 times x is going to be 15. 15 add 4y is going to equal 11. If I now subtract 15 from both sides, this side I'm just going to be left with 4y. If I subtract 15 from this side, 11 take away 15 is minus 4. And I'm now going to divide both sides by 4. If I divide both sides by 4, on this side I get y, and on this side I have minus 1. So x is 3 and y is minus 1. The second bit here, it's only worth 1 mark, so you shouldn't have to do any more work. It's just a case of thinking, and it's realizing that these two equations, each of those is a straight line. In order to find the intersection of two straight lines, I would solve the equations simultaneously, which I just did up here. So where those two lines meet, x is 3 and y is minus 1. So where they intersect is actually at the point 3 minus 1, which is what they're getting at here.